Hi, today we will be discussing trigonometry identities part 2. In the previous video, we talked about how to convert from degrees to radians and radians to degrees. We learned about the Pythagorean identities and the reciprocal functions. Now we will be learning about a few other trig identities. We'll start with even and odd functions. So it should be known that f of negative x equals f of x. If this is a true statement, that means that that function f of x is even. But if we have another function g, and if we take g of negative x and we get out that it's equal to negative g of x, then we have that g is an odd function. So sine, sine, tangent, cosecant, and cotangent are odd functions. And cosine and secant are even functions. So that means that sine of negative theta is equal to negative sine theta. And then we have the same for cosecant, tangent, and cotangent. These are all equal to negative of themselves. But on the other hand, we have cosine and secant, and if we were to take their negative theta, we get the same cosine theta. And this all comes from the fact that we have 4 quadrants named after the 6 main different trig functions. In quadrant 1, we have all trig functions are positive. In quadrant 2, we have that cosine and secant are positive. In quadrant 3, we have tangent and cotangent are positive. And in quadrant 4, we have sine and cosecant are positive. So that means that because here this side has a negative x value, but then we have a positive y value, that means that cosine and secant must be positive. That's why that cosine and secant are even functions. So now we are going to be heading on to sum identities. So the sum identities is the more hard ones to compute. And this we can compute them from the Euler's formula, which will be talked about in more higher order calculus. But the function is that e to the I theta, where theta is an angle, is equal to cosine theta plus I sine theta. And from this, we can say that if theta is equal to the sum of 2 different angles, say a plus b, then we can have that e to the I of a plus b in parentheses is equal to cosine of a plus b, which is what we want for cosine, and then we have plus I of sine of a plus b, which is the real part is what we want for the sum identity. And this is also just equal to factoring this out, we get e to the IA times e to the IB, which then we can say that if A is our angle, we have in parentheses cosine of A plus I sine of A. And then we're going to multiply this out by if the B was our theta. So we have cosine of B plus I sine of B. And if we were to carry out FOIL, we would get that e to the IA times e to the IB. You can try this out before you watch the solution. This is just equal to cosine A cosine B plus I squared sine A sine B. And then we add on I sine A cosine B plus I sine B cosine A. And this I squared is just equal to -1 because the square root of -1 is equal to I. And so we get that e to the IA times e to the IB is just equal to cosine A cosine B minus sine A sine B, and then we add plus I, we factor out the I and we get sine A cosine B plus sine B cosine A. So this is just interwoven. And remember that e to the I times a plus b is just equal to sine I sine of a plus b plus cosine of a plus b. And because we see an I outside of this parentheses, that means that sine of a plus b must be equal to what we desire, which is sine a cosine b plus sine b cosine a, and that cosine of a plus b is equal to cosine a cosine b minus sine a sine b. And if we were to take the difference of these, which is just a plus minus b, we would just have the opposite. So it would be, for sine of a minus b, we would get sine a cosine b minus sine b cosine a. And if we were to take cosine of a minus b, we would get cosine a cosine b minus plus, sine a sine b. So these are the two main difference formulas for sine and cosine. And if we were to want tangent of a plus or minus b, we just divide sine and cosine. And you can try this out by your own. Try to compute this out. And if you were to do this, you would get the following: tangent A plus or minus tangent B over 1 minus plus tangent A tangent B. So these are the three formulas for the sum and difference identities. Now we are going to head on to double angle formulas. So because we already know about sum and difference, we can just try these out pretty easily. So we're going to do sine of 2 theta. Sine of 2 theta is just equal to sine of theta plus theta. And if we remember, this is just equal to sine theta cosine theta plus the same thing. So we would just multiply this by 2. And so that means that sine of 2 theta is equal to 2 sine theta cosine theta. And that's our first double angle identity. Now if we were to do cosine of 2 theta, this is also equal to cosine of theta plus theta, which is equal to cosine theta, which is cosine squared theta, minus sine theta, which is sine squared theta. And this is our first main form of the cosine 2 theta, which is cosine squared theta minus sine squared theta. You can also say that as sine squared theta plus cosine squared theta is equal to 1, that means that sine squared theta is equal to 1 minus cosine squared theta. So that means that cosine 2 theta is equal to cosine squared theta minus 1 plus cosine squared theta, which means that it's equal to 2 cosine squared theta minus 1. And if you were to do it the opposite way, that is cosine squared theta is equal to 1 minus sine squared theta, you would get that it's equal to 1 minus 2 sine squared theta. So these are the three main forms of the double angle formula of cosine of 2 theta. And if you were to want tangent of 2 theta, you just divide sine of 2 theta divided by cosine of 2 theta, and you get 2 tangent theta over 1 minus tangent squared theta. So these are the three main double angle formulas. And if you want there are also the half angle identities. And these are just that if you wanted cosine of theta over 2, you would just take that, we're going to let A be theta over 2. And so that means that 2A is equal to our regular theta. And as we already know, cosine of 2A is going to be equal to 2 cosine squared theta minus 1, or in this case it would be a minus 1. We would have that cosine of theta, which is just our thing, is just equal to 2 cosine squared theta over 2, because it would have to be that divided by 2, minus 1. And so we can just get this on one side, our cosine of theta over 2, we can isolate it, and we get that this is equal to plus or minus the square root of cosine theta plus 1 all over 2. And then we can also get our sine in the same manner. So sine of theta over 2, if we were to take the same plugging in, we get sine of 2a is equal to 2 sine a cosine a. And so we get that sine of regular theta is just equal to 2 sine of theta over 2 times cosine of theta over 2. And as we remember, we have that 1 minus 2 sine squared theta is equal to cosine of 2 theta. And so that means that 1 minus 2 sine squared of theta over 2 is equal to cosine of theta. And so that means that sine of theta over 2 is equal to, if we isolate the sine squared theta and then take the square root of it, we get plus or minus 1 minus cosine theta all over 2. So these are the half angle identities of trigonometry. So these are the main types of identities which we're going to consider in trigonometry. And knowing these will be very helpful in progressing through calculus, such as limits involving the trig identities, derivatives, integrals, and so on and so forth. So I hope you guys enjoyed this video and were able to understand the trig identities. And you can check out my next videos on limits of trig identities in order to see how these help a lot in computing limits. Thank you, and have a nice day.